Hello everyone, my name is Caleb and today we are going to be making this ripple animation that you see behind me using React and Three.js. Okay, so to start making this animation, I'm just going to create a normal React project using create React app. So I'm just going to name the project app. After this, I'm going to install some additional dependencies that will allow us to work with 3D and WebGL in React, and we should be good to go then to start making our animation. So I'm just going to wait for this. Okay, and it's done. So I'm going to cd into app now and just install those additional dependencies that I mentioned. So I'm going to install Three.js. This really does most of the heavy lifting for us in terms of like WebGL and stuff. And I'm also going to install a reconciler called React 3 Fiber. This basically allows us to interact with Three.js using React components and JSX, which makes it really nice to work with, especially like if you're using 3D in React. I highly recommend using React 3 Fiber. It just makes things a lot nicer to work with, and you type like a lot more declaratively instead of like imperatively like Three.js is usually used. So I'm just going to install these and do some project setup. So I'm going to create an assets folder. So I'm just going to delete the styles there and just delete this stuff. Just cleaning up the template with a clean slate. I'm going to just be working in the app component, but if this was an actual application, you would want to, put this in a different component and do it there. But I'm going to, that was a typo. So I'm going to just use border box, so box sizing border box, and hide the overflow on the X. So overflow hidden on the X. And now I'm going to style this in a div, which is going to hold everything basically, and make it fill the whole screen. So just set width to that, height to that, and background color to that. Cool. So now I'm going to just set up some of my imports. So I'm going to import 3. I'm going to import the canvas from React 3 Fiber. And I also want to use an image asset, which I'll drag in right now. It's literally just a circle with a transparent border. The transparent border is important. You can really use any image you want, but this is what we're going to be using in our material to render each point. Again, the only thing that's really important about the exact image, when used in the texture, it should have a transparent background wherever you don't want it to be visible. So if it's just black, the black is going to show, so make sure it's transparent. So I'm going to import that image from assets, circle, PNG. Okay. Cool. So we're going to be using this circle image as a texture. And so I'm going to set up just my components just so I can show you how we can load this in. So we're going to have an animation canvas component. And this canvas component is going to basically wrap this canvas component, and then points is actually going to contain the actual animation. So first, I'm going to call this. Here, I'm going to call canvas. In canvas, I can set up some basic scene things. So I can like turn off color management, and I can specify camera position. So let me just do that real quick. Just looking up the values that work best. So camera position, I found this placement works kind of well, but again, this is entirely up to you where exactly you want the camera. Since I just noticed that this finished, I'm going to npm start so we don't waste that much time. and continue on. So this canvas is, I'm also just going to add, call the points component. And this brings me to an important concept in working with Three.js and React. So the canvas and points, these are going to take time to load. And the important thing is we need to specify fallback UI that should be displayed while that component is loading. Luckily, React provides a suspense component for this, and we just specify this fallback UI like this, for example. So I could say like div loading, and then put the animation canvas inside the suspense. And so now, while animation canvas is loading, this div is going to be displayed. Now, you should notice that if I did the exact same thing in points, I'm going to get an error. It's because while points is loading, the fallback UI that you specify has to be displayable where it's going to be. So the thing is, when you have inside canvas, you can only display 3 components, like Three.js components, and not normal like HTML components like div or paragraph or something. So instead of doing this, I'm just going to place null, and it should work. Yeah, so now let's get into actually displaying these points. So to display points, we can use the points class from Three.js. So the points class is used to display points, and it takes in a geometry of type buffer geometry and a material of type material. You can see that the default material is called points material. So a cool thing about React 3 Fiber is we can really like look at the Three.js documentation and get and figure out what the appropriate React code is going to be just straight from it. And I'll show you that here. So I know it takes geometry and material. So I'm going to go into my code, and I'm going to call the component that corresponds to the points class. Then I'm going to create a buffer geometry because that was the type of the geometry. I want to attach it to geometry. And I'm going to do the same thing for material. Remember, it said the default material, let me just pull it up. It says default is a new points material. So I'm going to use points material. And in here, you guessed it, I'm going to attach it to material. Now note, since we're at material anyway, I'm just going to set up points. I mentioned a while back that I was going to be doing loading, so we're going to just do that right now. The thing is that we cannot use the circle image just out of the box like this. We need to load it as a texture. So to do that, we can create an image text constant and use the use loader hook and use a texture loader like this and pass in our circle image to get the loaded image texture. And now we can pass this texture in the map property, and pass the color. I just found that this works, but again, entirely up to you. We also set our size. You can add size attenuation if you want to, it doesn't really matter. And the things you need to pay attention to though are setting transparent to false, alpha test to 0.5, and opacity to 0.1, or to 1.0. This basically ensures that the transparent portions are rendered transparent and not black. So that's why we need this stuff here. Now if we look in buffer geometry, we'll see that it uses buffer attributes to read and edit the data. So again, directly from the documentation, we go and take buffer attribute, and we're going to attach this to the positions of these points, because that's really what we want to be controlling when we animate our points. So I'm gonna pass in position. Cool. And now I'm going to pass in an array of positions, which I'll define above. Okay, but this isn't going to be the proper way to define the positions. Just for performance purposes, we're going to be using the use not meme, use memo hook, and pass like that. So we're gonna pass the arrow function like this, and we're just gonna create our positions. So here's how our positions are gonna look. So we cannot normally, like if someone were to ask me how would I represent positions, I would say 2D array, or like an array of tuples or something like that, where you're basically going to have an array of like your XYZ for each point, so on. But the thing is, we can't actually pass a 2D array, as far as I'm aware, to a buffer attribute, so we need a 1D array. And so how that's going to look is, instead of that, we're going to have something that looks like this. So note that each item or point is having 3 values in this array. And so in this way, we can define all the points, but just in 1 dimension instead of 2. So we know that each item or point has 3 values. So because of that, we're going to specify our item size to 3. Buffer attribute also needs to know the count, or the number of positions. And all that's going to be is just the length of this array divided by 3, because each position is going to take 3 of those values. So to calculate the number of positions, we're just going to do this basic arithmetic operation. Okay. So now let's go ahead and actually populate this positions with values. So I'm going to define this array locally, and then I'm going to return something that can actually be used in the buffer, which is a float32 array. I'm passing positions like this. Okay. So how can we populate these with values? Well, this is what's going to happen. I'm going to iterate over an index in my XZ grid, and I'm going to iterate from left to right on the x-axis. And then in that nested loop, I'm going to iterate from back to front. And I'm going to get the x comma z values. Then I'm going to determine the y value for that corresponding point, and finally add it all into positions. So to do that, we need to have 2 parameters, if you will. Not really, but like, I think you guys understand what I'm saying. So we're going to need to know the count and the sep. The count is going to be the number of points across one axis, and the sep is going to be the separation, or the distance between each point. So note that the count squared, or in this case like 10,000 points, are going to be in the entire grid, even though count is only 100. So let's write this loop. So I'm going to say use xi for like the index, the x, and I'll use zi for z. Cool. Now I can calculate the x and y values. Note that if I just did something like this, since xi is always positive, we're only going to get positive values of x. And 0, 0, like x, z, 0, 0 is going to be in the bottom left, if you will. But that's not what we want. We want our grid to be symmetric about the origin, and to be able to do that, we are going to have to offset this by half the number of points. So I'm going to subtract count divided by 2, and I'm going to do the same thing for z, but with zi. I'm just going to set y to 0 for now, and then we'll have an example that we can look at. This should just output us just a normal grid of just flat points. So we're going to now just push the x, y, and z to this array, and we're finally returning this. Note that use memo is going to require a list of dependencies. You'll see right here, the dependency list. So even though count and sep are constants, I'm just going to pass it in anyway. Probably a bad idea, but I'm going to do it. It shouldn't really matter if you do or not. Okay, so now if I refresh, let's see, did I miss something? Missing semicolon. Oh, that shouldn't be a comma. Okay. So if I go to localhost 3000, we can see just a grid of points. Cool. So now let's actually cast these onto the graph of the function. So now let's try to build a mathematical function for our wave animation. So consider the function sine of x. Graphing it, we see that sine of x clearly has a cyclic pattern. This cyclic pattern is defined by a period. A period is just the distance that this wave has to travel before it repeats, or this function has to travel before it repeats. So we can see that from this point to this point, the wave has a unique behavior, but after that, this portion is going to repeat this portion. So we would say that the period of sine of x is going to be the distance between these 2 points, and some people know this as 2 pi. Okay. The second notable feature about sine of x is the amplitude. The amplitude you can think of as how tall the wave is, and so amplitude in this case is going to be 1. Finally, we're going to look at this function, sine of x plus pi over 2. When we graph this one, we'll see it looks something like this. It is the exact same thing as this function, except it's shifted to the left pi over 2. This shift is known as phase shift. Putting it all together, we can create a general sine function. Note that I'm using kind of like sine and wave interchangeably here. So g of x equals a sine f times x plus theta. Note that changing theta is going to change our phase shift. Changing f is going to change our period. Note, if you look at something like sine 2x, it's going to have double the amount of peaks in the same amount of time. So the period is going to be half in this case. So we can use f to control our frequency. And a is also going to control our amplitude. So checking this, we can use a grapher. And if I look at like sine x squared plus y squared times 0.2, we can see we get a graph. The 0.2 is clearly driving this amplitude. If I add a small value like this, we can start to see some animations with changing the phase of our sine function. And finally, if I multiply all of this inside by 2, we can see double the amount of waves occur. So using these 3 parameters, phase shift, kind of something that drives the frequency and the amplitude, we can achieve a lot of different results. Okay, now that we understand how this function works, we can just use it directly. So remember, we have 3 parameters, and so those parameters were t for the phase shift, f for something that drives frequency, and a for amplitude. Again, these values that I'm using are just stuff that I found to work. You can definitely tweak it for the look you're going for. Now I'm going to use the use callback hook, again for performance, to basically just create a function that takes in an x and a z and outputs the corresponding y with the graph. So I'm going to call this a graph, use callback, take in x and y, z, and return math.sine. So we're going to take our frequency multiplied by the distance, not y, the distance to the origin, and indexing point for x, z, add my phase shift, and then multiply by my amplitude. Cool. Remember, we also need a dependency list, and this is really important because we want this graph to be rememwized every time this changes. So that's why we're putting these in here. Cool. So if we now we can call this graph right here and pass in our x and a z, which will evaluate and get the corresponding y value before we push it into positions. We should update this dependency list with the graph. So now we can see that these are actually casted onto the surface for the ripple that we got from this function. Now to animate this, it's fairly simple. We can use the use frame hook, which will basically call the function past every frame. and we just manipulate whatever variable we wanted to change. In this case, the phase shift, I'm just using as an example. And 15 is just arbitrary, really, it's first spin. And this note will make the graph be updated. So now the graph is the new graph that we want to follow. So we want to update all the y values instead of like clearing the whole position. So what we need to do now is get the current array of positions. So how we're going to do that is using a ref. So I'm going to say like buffer ref, and I'm going to create this ref up here. So buffer ref, let's use ref. And down here, I'm going to just say buffer ref current, and I'm going to get the array here. So now I have all the current positions. Now I want to modify these. I can use a very similar loop as before. And now I just want to set the y values to the graph, the new graph evaluated at x and z. But to do that, I need to know the corresponding index to that y value. So I can use an index to keep track of my position through the positions array. And I can do that, I'm just going to use I. So, sorry, not Java. I'm going to just use I. And since every position is going to go 3 values in the buffer array, I'm going to increment this by 3 every time. And remember, the values are stored in x, then y, then z from up here. So we can use I+1, remembering our 0 indexing stuff. And this should update all the y values with the new graph. Okay, so now finally we need to make sure this updates. So I'm going to say needs update equals true. And now if I didn't, well, I did screw something up. Circle, don't know how that got there. Use ref, let me just import this. While I'm at it, I'm just gonna format. Okay. And ta-da, okay, so we got our animation working, great. Now let's mess around a bit. I just wanna add one thing, I wanna add camera controls. So if you look, Three.js is actually gonna provide orbital controls out of the box, and it has a class to do this. But unfortunately, React 3 Fiber doesn't have out of the box support for it. But that doesn't stop us, because React 3 Fiber provides us a way to take some definition that you just find on like GitHub that uses Three.js and turn it into a JSX component that we can then use. And the way we do this is using extend. So first, I'm going to import that orbital controls that I just showed documentation of. So orbit controls, and I'm going to import this from, I think it's like JS, yeah, controls and orbit controls, yeah. And now I'm going to call extend on this orbit controls, and this will basically create the appropriate JSX component with the same name, except it's lower camel case. So now I'm going to make my new component, so I'll call it camera controls, just so it doesn't clash. And I'll call orbit controls. For lowercase this, gotta remember that. Okay, so how does the orbit controls actually work? Well, if we inspect right here, we'll see that what Three.js is really doing, or WebGL rather, it's drawing everything on a canvas. So orbit controls is going to allow us to like pan the camera around and manipulate the camera using mouse. So to do that, it needs a way to get the current camera and the DOM element, or the canvas, in the scene. We can actually do this by using the use3 hook from React 3 Fiber. And using this, we can kind of extract, if you will, the camera and the DOM element from use3. And so now that we have this, we can pass this in as arguments. Element. And this basically allows, it lets orbit controls know what camera and DOM element to operate on. Now I also want this, I want my orbit controls to just make the camera slightly rotate if no mouse movement, if no mouse input is being sent. So I'm gonna turn on auto rotate and set auto rotate speed to that, something really small. Now we can finally animate this. The reason we really need to animate this is we need to call update on this orbit controls component, and every update it'll take in the mouse input and actually do the adjustments to the camera. So for animation, we're going to use frame. So every frame we want to update it, and so we're going to get some, like, pretend we have a controls ref, and we can call update on this ref, and I'm just going to make that ref right now. So we want to be able to update this orbit controls component, and the only way to do that, or I shouldn't say only, but like one of the ways to do that is with the ref. So controls ref, use ref. Okay. And so that should set the reference up, and now we can use that reference in our use frame to update. Cool. So we get this warning, it's never defined, it's defined but never used. That's just because we should add camera controls. And now we can see I can like move this around, rotate it, I can zoom in and out, I can pan, I can do all sorts of things. So this shows how orbit controls can really help. Okay, now this is mostly done for the coding part, but I also want to show you, like, with the system that we set up, we can actually achieve a bunch of different results. So if I just change the separation and count, bump the separation down and just make the count super high, refresh, we can see that it almost looks like a mesh animating. Obviously you could triangulate a mesh and like actually do the work, but like this is a cheap way to do it. That's not very performant, but we're gonna ignore that. Another thing that you can do is actually animate variables other than t. So let's say I want to animate the amplitude of it. So doing this, we can see we get this cool effect of the waves kind of growing in like height, which I think looks kind of cool. If I zoom out, looks kind of like raindrops in a random pattern. So yeah, the point is there's a lot of different results you can achieve with the system that we've just set up, and it's really up to you to tweak things. And you know, one thing you could do is, instead of putting the points on a grid, you could put them in a circle so that you don't have these corners that are kind of radially like awkward because they're looking at ripples that others don't have. There's a lot of stuff you could do. Thank you for watching this tutorial using React and Three.js. The source code and other learning resources are going to be linked in the description, so be sure to check that out. And if you would like more content like this or have any questions, please let me know in the comments. See you in the next video!